11 with radicals. And the first thing I want to start with is just a simple distinction between rational numbers and irrational numbers. A rational number can be written as the ratio of two integers. An irrational number cannot be written as the ratio of two integers. So just a simple distinction there. Now, the next topic I would like to talk about is the density of the number line, and it's something that we take for granted, but basically between any two real numbers, you can always find another real number. And I just wanted to do a few little exercises with this. So the density of the number line states the following. If I have two rational numbers or two real numbers, we'll use A and B, and A is less than B, if I'm looking for a number halfway between, the way I would find the number halfway between will be using this little expression. If I'm looking for a number 1/3 of the way between, if I'm looking for a number 1/n of the way between, the distance between. So number 29 from the homework set, find the number that's 1/5 of the way from -2/3 to 3/5. So I have A is -2/3, B is 3/5. So here's my little formula. And then cleaning this up, getting a least common denominator, you end up with giving you -31/75. So if I come back to the original problem and I compare everyone with a common denominator, this is simple and it's something that we've always taken for granted. So I just wanted to do a few problems just to show you that you can always find another number between. Okay, now let's go to some basic radical properties. And we have talked about this topic already this year, but let's just go back and revisit the basics. So here's my radical, my basic radical. The index indicates the root that I'm finding. The number underneath the sign is called the radicand. Every positive real number has two square roots. The principal square root is the positive root. It's our default root. So if no notation is given, it's assumed that you're looking for the principal square root. If you have a negative sign in front of the radical, then you're looking for the negative root. If both positive and negative is in front of the radical, then you're looking for both roots, both square roots. So just a little basic, and SQR, that's my abbreviation for square. And some basic properties with products. The square root of A times B is equivalent to the square root of A times the square root of B, and the quotient is the same, equivalent expressions. And now let's look at some simplifying using absolute value. And I'm going to simplify this expression and then ask you to answer the question that's in blue. And we'll have a class discussion. So watch the video, give me your, bring your best answers to class and we'll talk about it. So when I simplify this, I end up with 15 times the absolute value of x times y squared with no absolute value bars times the absolute value of z to the 5th times m to the 4th without absolute value bars. So in class, I want you to be prepared to discuss why absolute value bars are necessary on some of the terms and absolute value bars not necessary on the other terms. So just observe this, write the answer down, and come up with a good answer for class discussion. Okay, moving back to an old topic, we're now going to solve something we could have solved with factoring. I'm going to give you two methods. So I can solve this with factoring. That's an old skill. Or you can use square roots. And And since chapter 11 is all about radicals and roots, now that becomes a good option for you. So in the world of factoring, I would set this equal to 0. And I would have 2x plus 5, 2x minus 5. And then my x values would be positive and negative 5 over 2. Square root method, I would divide both sides by 4. And then I would take the square root of both sides. The square root of x squared is x, and then this gives me the positive negative 5 over 2. So the absolute value bars were needed when I was simplifying. Here I was able to solve this by factoring, therefore using both roots, and the square root method, I'm using both roots. So I would like for you to think about this and have some comments for class discussion the next time we have class. Okay, a little word problem using radicals. A circle inside of a square. So I drew a little sketch. A circle inside of a square, and the circle's just touching the sides of the square. This is not perfect, but I guess it serves the purpose. The area of the square is given. So the area of the square is 341.9. And if I'm analyzing this, or the area of the circle rather, the square is made up of one side would be 2 radii. The area for the square would be one side squared. So if I can find the length of the radius and double it, then I can find the area of the square. So I would leave the pi value in your calculator as long as possible. That gives you radius. I rounded to 2 decimal places, and I have 10.23 as my radius. That means a side of my square, just doubling that number. One side of the square is 20.86, and the area of the square will be 435.32 centimeters squared. So just using the square root property, getting used to using radicals again, that's what this chapter is all about. And finally, the last topic is probably something new. It's a semi-perimeter. And the semi-perimeter allows us to find the area of polygons without the standard formula. So the semi-perimeter is represented by lowercase s, and it's 1/2 the sum of all the sides. So here, this formula would represent the semi-perimeter for a triangle, A, B, and C being the sides of the triangle. So I've asked you to do 2 homework problems, and I will do number 11 right now. So I'm asked to find the area of a triangle if the side lengths are 14, 19, and 25. I do not know the height of this triangle, so my traditional area of a triangle I would need some trigonometry in order to figure out what the vertical height of the triangle is, the altitude of the triangle, the height, the perpendicular height rather. And this is a way around that, a way around using trigonometry to find the area of a triangle when I do not know what the height is. So my semi-perimeter so it's 1/2 of 58. So my semi-perimeter is 29. So the area of this triangle, I would calculate the area of this triangle by multiplying the semi-perimeter and the difference of the semi-perimeter in each of the 3 sides. And getting through all of the calculations, the square root of that number, so the area of a triangle with the 3 side lengths given